This year, we finally have a machine that could theoretically detect the theoretical infamous dark matter particle. Basically, what dark matter is a substance that takes up over 85% of the known mass in the universe, and yet it is something that we can't observe or detect in any way other than seeing its effects gravitationally around us. We can only observe this effect of dark matter by looking at the mathematical formulas for galaxies that we would normally predict wouldn't be able to stay in place had it not been for some mysterious form of mass that is completely invisible. A certain particle that's been theorized to be associated with dark matter has been known as a WIMP particle, or a weakly interacting particle. This on top of the fact of us knowing that we should be able to come up with some sort of machine that will be sensitive enough to detect it. Well, now we finally have a machine and an experiment which its only goal is to detect this notorious dark matter, and this is known as the Lux Zeppelin. This machine will be located approximately 1 mile underneath the Sanford Underground Research Facility. The process that this all starts with, although it being kind of complex, is rather similar to the way that we found out the existence of the popular neutrino. Neutrinos are also particles that fly through us in the billions and trillions on an everyday basis and are very weakly interacting with normal matter, but yet they were discovered in the same fashion, through very deep underground facilities that have very sensitive equipment. The basic layout of the experiment includes towers with crystal-like structures within them. These crystal and silicon detectors will be used to detect any form of dark matter, whether it be through our theorized WIMPs or through any other possible detection. Theoretically, if a dark matter particle or WIMP interacts with any of these detectors, the collision will disturb electrons and cause a chain reaction within the crystal, amplifying the actual impact of the dark matter particle. And the reason it needs to be 6,800 feet underground is because even the smallest interferences of electromagnetic radiation or even the smallest sound can set off these things to go haywire. And the final and most important part of the experiment contains 10 tons of liquid xenon, which is a quarter of the world's annual supply, surrounded by a shielding of titanium. And when a supposed WIMP or dark matter particle interacts with the xenon, it will create both light and an electric charge. And over 500 sensors of this light will be able to determine the exact properties of the particle that interacts with it and determine whether or not it is truly dark matter, or just an outside disturbance, but hopefully dark matter. And if this experiment proves to be fruitful, we'll finally be able to have a mathematical constant of dark matter and have a new understanding of what exactly makes up the universe that we live in. So we can only hope, as we wait for this experiment to garner results, that time proves to be a success.